Today's class we will go for one more algorithm comes under the greedy method, that is single source shortest path. The other name of this one is Dijkstra algorithm. So this is the given graph, which is capital G, which is represented by capital G, which contain some set of vertices and a set of edges. So here may I know how many vertices are there? Total 6 vertices are there. And if I count the edges, 1, 2, 3, 4, 5, 6, 7 edges are there. So here in this, I am going to take the starting vertex as capital A, and I will apply this Dijkstra algorithm to find the shortest path from the source you have selected capital A to remaining all edges in the given graph, or remaining all vertices in the given graph. So this is the aim of Dijkstra algorithm. So let us know how to do this one step by step. First one, before starting this Dijkstra algorithm, I will tell you some notations which I am going to use in this Dijkstra algorithm. So that is U, comma V. So where this U represent the starting vertex. Okay, while applying this Dijkstra algorithm on this graph, so from which vertex I am starting, that is going to be represented by U. And capital V, which is representing the ending vertex. So, or visiting vertex. So, which from U to V, which is nothing but U is the source of visiting, and V is the vertex we are visiting. These are the two notations, and I am going to represent D of U, which is representing the distance at U. So this is going to be represent distance at U, and D of V is going to be represents that this is distance at vertex V. What is V? Ending vertex or vertex which we are visiting. And I am going to use another thing, that is cost function. This cost function I am going to write U comma V, which is conveying that the weight of U comma V edge. So for example, in this diagram or in this graph, I am going to represent like this. So A comma B, which is nothing but I want to know what is the cost of A comma B, which is showing that the weight of edge between A comma B. So what is the weight of this edge? 4. So this value is 4. So like that I am going to use this terminology in our Dijkstra algorithm. And one more thing, I am going to generate one simple equation which conveys that the weight how can we update while applying the Dijkstra algorithm. So for example, here before that I am going to draw one simple graph, capital A and capital B, capital C, like this it is available. So here the weight is 4, the weight is 2, like this it is available. So when I select the starting vertex as capital A, so to move from A to A, how much distance you need to be travel? 0 distance. So as of now, I am at A. I did not visit this B. So when you do not visit this B, when you are standing at A, you need to consider it is going to be represented by infinitive distance. And C also you didn't visit it. Again, you need to represent this one as a infinite distance, because I did not visit B from A. Is that clear? Now I want to traverse from A to B. So how can I find the distance? So here the distance, how can you calculate? What is the initial distance available at B? Initial distance available at D, B is infinitive. Okay, so instead of infinitive, we have another one, that is for moving from A to A. So already how much distance you have traveled at here? 0 distance. So distance at A is 0 plus to reach B, how much distance I need to be travel? A to B, 4 distance. Okay. So how can I represent this 4? This is the thing I have written. So cost between A comma B. Okay. So this is also one of the path is available to reach B. What is the already distance available at B? Infinitive. What is the alternative path is available? Distance which is traveled up to A and from A to B. So it's a cost. If I do these two sum, 0 is the previous distance at A and cost A to B is 4. Okay. So here this is also another new updation of distance to B. So here, will you travels with the infinitive distance or will you travel with the 4 distance? From these two, which one is the minimum? 4 is the minimum. So that what you do from infinitive, which is going to be removed, and you need to replace this one with the 4 weight. So how did you calculated this distance at B? By taking the minimum from these two. So here, this is going to be right like this. So distance at the vertex which you are writing at V is the new thing which is going to be represented by minimum either from distance at B means distance at V or distance at A is nothing but from A to B you are visiting. Okay. So this is going to be represented by distance at U plus cost between A comma B. So using this equation, I am going to update the distance table. Okay. So these are the terminologies, and using this terminology, we need to apply this Dijkstra algorithm on this S. Now let us start how to apply Dijkstra algorithm on this graph. First step, we need to go for initialization. What initialization we need to do? So first one, we need to select, or first initially we need to write two sets. First one is visited vertices. So initially visited vertices are empty vertex. Okay, we because no one vertex has visited as of now. Next one, non-visited vertex. So what are the non-visited vertex? I did not start anyone. So I am going to include these all A, B, C, D, E, F. So I am going to remove one by one and I am going to include the into visited set. So we need to continue this one until this non-visited vertex set becomes null. Okay. So let us know how I am going to update these things. Next, first step, I need to pick one vertex as a starting vertex. So from this graph, I am going to take this capital A as a starting vertex. So start vertex is capital A. So when you select capital A as a starting vertex, to move from A to A, how much distance we need to be traveled? 0 distance. How can I represent this one? Distance at capital A is going to be represented by 0. Next, did I visit any other vertex till now? I did not visit it. When you did not visit, the remaining all vertices you need to represent with the infinitive. Is that clear? So here, this distance at 0, I am going to write at this place, and remaining all distances I am going to represent with the infinite. Right. First step is completed. Okay. So visited is MD, non-visited is A to F, and I have taken starting vertex as capital A and distance at A is 0, remaining all vertices are infinite. This is completed. Next, I will go to the second step. So what is the second step? Step 2. From the non-visited vertices. So these all are the non-visited vertices. From that, I need to pick a vertex. That vertex distance should be the smallest. So here, these are the vertices. Which vertex distance is small? A. What is the A's distance? 0. And remaining all are infinite. So here, smallest distance vertex. What is the smallest distance vertex? Capital A. This one I have taken. So from this A, what are the vertices you can visit? So here I am going to write the, listen this one carefully. Capital A is the vertex I have picked from this non-visited vertex, which is the shortest distance. So this A. So from this A, which vertices I can visit? From A to B, I can visit. From A to C, I can visit. So from A to B, I can visit. Similarly, from A to C, I can visit. Okay. So here, in this case, you need to take this A as a U and B as a visiting vertices. So here, just now I said one equation, how to update the vertices. So what is the equation I said? Distance at V. V is the vertex, this one. How can I represent this one? Minimum I need to be calculate from distance of vertex V and distance at U plus cost between U comma V. Okay. So I am going to substitute this U comma V values at this case, and I need to calculate which distance we need to be pick. Minimum distance I need to pick. So if I substitute this U comma V in this, let me know what are the updated values. So distance, minimum I need to be calculated. So distance at V. Distance at V means distance at B, comma, distance at A plus cost between A comma B. Okay. I am writing only for this first one. From second one onwards, directly I will write the values. So here, what is the distance at B? Minimum. What is the distance at B? Infinite. Next, what is the distance at A? 0. Plus cost between A comma B is, what is the cost between A comma B? 4. So from this, which one you will pick? Either infinitive distance is the best one, or 0 plus 4 means 4 is the best one. 4 is the best one. For which distance you need to write? Distance at B. Okay. Distance at B need to be updated with the minimum value from these two. So from these two is the 4. So this is going to be assigned to distance at B. Similarly, I am going to write. So minimum value from distance at C or distance at A. What is the U at here? U is nothing but A plus cost between A comma C. So I am going to write minimum distance at C right now is infinite, comma distance at A is 0 plus cost between A comma C is 2. So how I am going to write this one? Minimum infinite comma 2. What is the minimum from infinite comma to 2? So for which place I need to write? Updated distance at C. So I am going to overwrite this value with this one. So let us know what happens. So previously distance at B is infinite. I am going to erase this one and I am going to update its value with the 4. What is the distance at C? Distance at C is previously infinite, but updated value is 2. Next, remaining all as it is, I am going to copy 0 and infinite, infinite, infinite. So here, once this step is completed, what can I do? I need to update the visited and non-visited vertices. So let us know how I am going to update this one. Visited vertices. So here, which one is completed? U is completed. You need to write this U value into the vertex visited. So A is the visited. And what is non-visited? So non-visited are remaining all vertices. So from this group, A is removed and remaining vertices I need to be right inside the non-visited. So this is B comma C comma D comma E comma F. Yes, this one is completed. Next, I will go to the next step. So next step number 3. So the same thing will be continued. What I did in step number 2, I have picked the smallest distance vertex from non-visited vertices. So distance from non-visited vertices. So similarly, here also I need to find smallest distance from non-visited vertices. So here, what are the non-visited vertices? B, C, D, E, F. So here from B, C, D, E, F, which is the smallest one? 2. So which vertex having 2? C. So I am going to pick C as a next vertex. So let us know how I am going to do. So from C, which vertices you can visit? From C, we have only one vertex can be visit. This is E. So I can go from C to E. Now what I need to calculate? Distance at E. Let us know how I am going to calculate. So let me know how can you write this equation? This is U, this is V. So distance at E, which is going to be represented as minimum of distance at E, comma, distance at C plus cost between C, comma, E. Okay. So let us know what is the values we will get. Minimum value. What is the distance at E? Distance at E is right now, which is infinite. What is the distance at C? Which is 2 plus cost between C comma E is 3. Cost between C comma E 3. So here may I know what is the result? Minimum is 5. So at what place I need to assign? D of E. So let us know what is the updated this distance table. So which one I need to be updated? Distance at E. So distance at E is previously infinite. I am going to rewrite this one with the 5 and remaining as it is I need to rewrite. So 0, 4, 2, infinite, infinite. This is the step 3 updation. This is step 3 updation. This is step 2 updation. This is at step 1. Yes, which is completed. And what can I do? I need to update the visited and non-visited. So visited vertex. What is the visited? So previously visited is A, and what is the another thing I need to include? This C. So A comma C, which are comes under the visited, and which is non-visited, which are non-visited. The vertices excluding A comma C comes under the non-visited. So what are the things are there? B, D, E, F. So like this, we have completed the step 3. Next, we will go for next step, which is step number 4. Next step, step number 4. Next, what can I do? I need to find the smallest distance from non-visited vertices. So what is the smallest from non-visited vertices? So B, D, E, F. So B is 4, D is infinitive, E is 5, and F is infinitive. From these 4, which is smallest? 4 is smallest. So which vertex is smallest? B. So smallest vertex from non-visited vertices is B. Next, what is the next step? I need to know what are the vertices I can visit from B. So from B, I can go to D. Next, from B, I can go to C. Now what can I do? I need to find the distance at D. So how can I do? Directly I am writing. I won't write that entire equation. So minimum value I need to find. So what is the first thing? Distance at D. What is the distance at D? Infinitive, comma. How can I find distance at B? What is the distance at B? 4 plus what is the cost between B comma D? Cost between B comma D is 10. So will you go for 14 or will you go for infinitive? So we need to take 14. So this is the distance at D. Next, similarly, I need to find distance at C. So how can I calculate minimum? So distance at C. What is the distance at C? Distance at C is 2, comma. Next, distance at B. What is the distance at B? 4 plus what is the cost between B comma C? B comma C cost is 5. So this is 9. Will you go with the distance 2 or with the distance 9? So minimum is 2. So I am going to take it as a 2. So where can I update this one? D of C. Now let us test what is the updated results. So distance at D is 14. So distance previously it is infinitive. I am going to replace this one with the 14. Next distance at a C is 2. So previously 2 is there. Again 2 is I have taken. Next remaining as it is I am writing 4, 0 and 5. This is infinitive which we got at the step number 4. Next, once it is completed, what can I do? From this, I need to write visited and non-visited. So what is the visited vertices? Visited vertices I need to write. So visited previously are A comma C. I am going to include this B also. A, C, B. Which is non-visited. So excluding this, remaining all vertices I need to write. So non-visited are, so A is B, C is completed, D, E, F. So this is completed. Next, I will go to step number 5. Step 5. Again, what can I do? I need to find the smallest distance from non-visited vertices. What are the non-visited vertices? D, E, F. So D is 14, E is 5, and F is infinitive. Which is the smallest? 5 is the smallest. So I need to pick E vertex. So smallest distance vertex from non-visited is E. Right. Next, what can I do? From E, what are the vertices I can visit that I need to pick? So this E is the U. And from this E, which vertex I can visit? from E to D I can visit. So D, I am going to represent this one with the E. So now how can I calculate distance at D? So which is going to be calculated by taking minimum value at a distance at D. What is the distance at D? 14, comma. How can I write the updated one? So distance at E. What is the distance at E? 5 plus cost between E comma D. What is the cost between E comma D? 4. Right. So here this is 14 and 5 plus 4 is 9. So will you go with the 9 distance or 14 distance? 9 distance. So I am going to pick this one as 9 and I am going to update this value at a distance at a D. So let us know what is the updated value at a step number 5. So I am going to take step 5 updates. Which one I have updated? Distance at D. So distance at D previously 14. Now it was updated with 9. And remaining all I am going to take with the same values. Next, after updating these array values at step 5, we need to write the visited and non-visited vertices. So visited vertices are A comma C comma B, which is already I am picking selecting from this previous step. Along with that, this U I need to include. This is E. S. Which are non-visited vertices. So non-visited means excluding this remaining all vertices I need to write. A, B, C, D still it is not yet completed. E already visited. F I am going to write. Still we have 2 more vertices. Next, I will go for step 6. Right. What can I do? Again, I need to find the smallest distance from non-visited vertices. So I need to pick a smallest distance vertex from non-visited set. So D and E. So D is 9, E is infinite. So which one I need to take? D I need to take. Next, from D, which vertex I can visit? Only F. So here I am going to write this one. So from D, D is said to be U. From D, I can visit only F. Okay. So this F is V. Now how can I do? Minimum I need to find. So I need to know distance at F. So how I am going to write? You check it. Minimum value from distance at F. So what is the distance at F? Infinite, comma. Distance at D. What is the distance at D? 9 plus cost between D comma F. What is the cost between D comma F? 11. So here minimum value infinite comma 9 plus 11 is 20. So which one you pick? 20. So now I have to update distance at F with the 20. So again I am updating. So previously infinitive is there. I am going to represent this one with the 20. And remaining as it is, they are available. This is 5, 9, 2, 4, 0, which was updated at step number 6. Next, I will go for step number 7. Before that, I need to update which are visited, which are non-visited. So visited vertices. So what is the visited vertices? So previously ACBE, ACBE, along with that new more vertex is introduced, that is D. and which is non-visited vertices. So non-visited vertices are excluding this. I need to write remaining. So remaining is only F is pending. Right. Next, we will go for step 7. What can I do? Again, I need to find the smallest distance vertex from non-visited vertex. So how many non-visited vertexes are there? Only one, which is F1. So smallest distance vertex from not visited. We have only one that I am going to represent from F. Next, what can I do? I need to find the vertices which can be visited from F. So here from F, no edge is there or no vertex is there. So when no vertex is there, then what can I do? There is no need to find any new distances. Simply, I need to include this F into the visited. So let us know what is the visited. So visited vertices is going to be include F also. A, C, B, E, D, and along with that, I need to add F also. F. And what are the non-visited vertices? So which becomes empty. Once non-visited vertices becomes empty, you can stop the process. Okay. And what are the updated values are there that you need to consider as a smallest distances from selected vertex, source vertex. What is the source vertex? Capital A. So now I am going to write the distances. S. Finally, we need to find the distances from A to remaining all vertices. So from A to A, how much distance you need to travel? 0 distance. If I want to go from A to B, how much distance I need to travel? 4. From A to C, what is the distance? 2 distance. From A to D, how much distance? A, 9. From A to E, what is the distance? 5. From A to F, what is the distance? 20. These are the shortest distance from selected source vertex A to remaining all vertices in the given graph. So this is the way you need to perform Dijkstra algorithm.